We're looking at homework for section 9.1. This is question number 13. Calculate the correlation coefficient R, letting row 1 represent the x values and row 2 the y values. Then calculate it again, letting row 2 represent the x values and row 1 the y values. What effect does switching the variables have on R? So, we're going to build a table. I've put my x values, all 7 of them, in the top row, my y values in the second row, and then I've added in rows for x times y, x squared, and y squared. We're going to start with x times y. 10 times 121 is 1210. 24 times 191 is 4584. 40 times 178 is 7120. 49 times 179 is 8771. 58 times 192 is 11,136. 67 times 125 is 8375. 74 times 128 is 9472. How about the x squareds? 10 squared is 100. 24 squared is 576. 40 squared is 1600. 49 squared is 2401. 58 squared is 3364. 67 squared is 4489, and 74 squared is 5476. For the y squareds, 121 squared is 14641, 191 squared is 36481, 178 squared is 31684, 179 squared is 32041, 192 squared is 36864, 125 squared is 15,625, and 128 squared is 16,384. Now that we've got all those products computed, we can add up the sums of each row. For the x's, those x values add up to 322. The y values add up to 1114. The x times y values add up to 50,668. The x squared values add up to 18,006. And the y squared values add up to 183,720. We need to use those values to compute the correlation coefficient. So I'll put them in a table in the upper left. Now we'll use the formula. R equals n times the sum of the x times y's minus the sum of the x's times the sum of the y's over two different square roots. The first square root is n times the sum of the x squareds minus the sum of the x's squared, and the second square root is n times the sum of the y squareds minus the sum of the y's squared. The n is 7 because we had 7 data points, so we start inserting the values from our table along with the n value. R equals 7 times 50,668 minus 322 times 1114 over the square root of 7 times 18,006 minus 322 squared times the square root of 7 times 183,720 minus 1114 squared. We have 6 multiplications to do, and when we multiply, we get 354,676 minus 358,708 over the square root of 126,042 minus 103,684 times the square root of 1,286,040 minus 1,240,996, which simplifies to negative 4,032 divided by the square root of 22,358 times the square root of 45,044. When we plug that into our calculator, we get negative 0.1270531,897, rounded to 3 decimal places, gives us a correlation coefficient of negative 0.127. The second part of this question asks us to calculate the coefficient R, letting row 2 represent the x values and row 1 the y values. So let's recall the formula for the correlation coefficient along with the table of values we got from part 1. What's going to happen when we switch the rows around? Well, in our table, the sum of the x's and the sum of the y's will change positions, and the sum of the x squareds and the sum of the y squareds will change position. So the table looks like this. But when we do that, if we look at the formula, In the formula, the n doesn't change because we still have the same number of data points. The x times y's don't change because when we flip-flop the x's and y's, we're still multiplying the same values together, and their sum will still be the same. So the first term in the numerator is identical. The second part says multiply the sum of the x's times the sum of the y's. So in part 1, we were multiplying 322 times 1114. Now we'll be multiplying 1114 times 322. So you get the same answer for that. So the entire numerator stays unchanged. In the denominator, the first square root had n times the sum of the x squareds minus the sum of the x's squared, and the second square root had n times the sum of the y squareds minus the sum of the y's squared. All that happens when you switch your x's and y's around is the square root that we had on the left originally will be on the right, and the square root that we had on the right originally will be on the left. But we'll still be multiplying the same two values together, and thus the entire denominator stays the same. So if the numerator and the denominator both stay the same, then that means the value of this correlation coefficient will stay the same, which means that the new r is also negative 0.127. So what effect does switching the variables have on the correlation coefficient? The correlation coefficient remains unchanged when the x values and the y values are switched. And that's your answer.